All right, so for this problem, it says which expression is equivalent to the given expression? Assume the denominator does not equal 0. So let's expand on this. A to the third power means A times A times A. Times B to the fifth power means I'm going to have 5 B's, right? So 1, 2, 3, 4, 5. And then in the denominator, I have 1, 2, 3, 4 A's, and just 1 B, B to the first power. So when it comes to the A's, A divided by A is what? What's something divided by itself equal? What's 3 divided by 3? 1. What's 2 divided by 2? 1. So when we divide something by itself, it reduces down to 1. So all these will reduce down to 1. So, but if you notice, there's 3 A's on top, 4 on the bottom. So I'm left with 1 A all by itself on the bottom. Now let's do the same thing with the B's. I only have 1 B on the bottom. That will reduce with 1 B on the top. So then my answer is I have 1 times 1 times 1 times 1 times B times B times B, 4 B's. So that becomes B to the fourth. And then I have 1 times 1 times 1 times A times 1, which becomes just A. So B to the fourth over A. And then remember, A cannot equal 0 because that's the denominator. Well, there's a shorter way to do that. I could do this. I could say A to the third power, B to the fifth power, all over A to the fourth power times B to the first power. And if you remember, we did this way back in January. We're going to subtract the smallest one from the biggest one. So 3 is smaller than 4, so I can just say minus 3 here. But whatever I do on the top, I also have to do on the bottom. This becomes A to the 0, which is just 1. 1 times, oh wait, let's do the B's. I'm going to subtract 1 here and subtract 1 here because 1 is smaller than 5. This becomes B to the fourth. This becomes B to the 0. This becomes A to the 1. So this goes away, and I'm left with B to the fourth. This goes away because it's equal to 1, and I have A to the 1. The exact same thing. Any questions on that? Let me zoom out so you guys can see the whole thing. Okay.